Chatham is located in southwest Trinidad along the south coast. The area is sparsely populated and the quarrying of porcelainite is economically important. This topographic map confirms that the area is sparsely populated, with most of the houses located along the only road within the area. The Kugler surface geology map shows that the area is dominated by the Eyring Formation with thick porcelainite beds. 2 wells have been drilled in the area, neither of which found any hydrocarbons. Today we are down in Chatham at Chatham Beach. So as we look around, we see basically a number of abandoned buildings. It gives you an idea how undeveloped the area is. So as we are on Chatham Beach and we're looking towards the west, we see piles of red stones, which are called porcelainite, piled up on the beach itself. This has come from the cliffs in the distance, and it has been transported by something called longshore drift. Now, as we look on the beach itself, we see the remnants of 2 posts sticking out of the sand. And as we look further out into the sea, you notice there is 1 more post. This is actually the remnants of a jetty that existed back in Chatham back pre-1960s. When Chatham was a port for agricultural produce on the south coast. That has long gone. So as we look in the background there, this is the remnants of a hotel that actually closed down back around 2004, and there's actually no other development in the area. At White Cliff, we see a sand-filled channel that cuts down into the underlying lignite bed. So we are approaching what is popularly called White Cliff because the sands are light brown in color as compared to the red cliffs that we will see shortly. So we are in the Eyring Formation. And here we're actually looking at lignitic clays that exists within the Eyring Formation. So as we come closer, one thing we would notice is that for lignite deposit there is no trees or tree trunks. We're actually seeing just a homogeneous mass of material. The other thing we notice is the yellow color. That is sulfur, which is the result of the bacterial action digesting the lignite, and sulfur is excreted as a product. So we see a fairly thick lignite bed. It's probably about 20 feet thick, and we're not actually seeing any layers. Above that, we're seeing gently dipping parallel bedded sands.
So as we approach the eastern end of this sand body, we notice that dips are in the opposite direction, and once again underlain by the same thick lignite bed. What this outcrop may represent is a sand-filled channel which is cut into the underlying lignites. On the beach itself, we see the lignite bed being exposed. So let's take a closer look at the lignite here again. What we see, there's a fairly sharp contact between the lignite and the overlying sands. And there's actually a strong sulfur smell. This material actually is a lignitic clay, not a pure lignite. And probably represents some kind of swampy area. So here we actually see two channels that are cutting into one another, a lower one and an upper lignite-filled channel. In the upper channel, we're seeing excellent cross bedding, and as we go across, we see another channel cutting into that.
Slightly further to the east, we see channelized sands, lignitic claystones, sandy lignites, and lignites, which are forming either erosional channels or indicate the lateral migration of sediments.
So here we have a closer look at the outcrop. We see strong angularity here, which is suggesting erosion by an overlying shale-filled channel. Those beds are also parallel laminated. One of the things we're noticing is that there is no bioturbation. In the lower unit, we are seeing a fair amount of sand, strongly cross-bedded, but also abundant lignite fragments.
Lignites begin as an accumulation of partially decayed plant material, or peat. With the application of pressure and heat, it compacts and changes to bituminous coal, anthracite, and ultimately graphite. These lignites at Cedrus Point are made up primarily of water and contain a fair amount of sulfur, What we're really looking at is a carbonaceous shale, and what we have seen in places is that the lignites grade upwards into organic rich claystones. There are two possible origins for the lignites observed in the outcrop. The first involves an in situ origin within mangrove and sedge swamps developed behind estuarine barrier bars and spits, while the other involves erosion and resedimentation of existing lignites.
So here we are seeing a fairly large tree trunk in the sand. It's not known whether it's a modern tree trunk, but given its proximity to the lignite, we have to assume that is originally part of the lignite. So here we are looking at basically unstructured sediments, which probably represent modern deposits or Pleistocene age material, because as we move across to the west, we see that there is no transition from one to the other. So these beds are dipping roughly to the southeast. They're parallel bedded. Let's have a slightly closer look. So as we continue walking along the outcrop, we notice that we start to see significant amounts of cross bedding, and at the base of this unit we see another lignite bed. Once again, we notice that there are no woody materials, and it's underlain by a clay, and it grades upwards into sands.
At this outcrop, we see channels overlying well-bedded lignites. Here we see tree stumps in growth positions. The bulk of the lignite is made up of leaves, seeds, and other plant materials.
So we are looking at the top tops of another lignite bed here, and as we walk across, we see the remnants of tree trunks. So these lignites were, this particular lignite was probably formed in some kind of swampy deposit. At this point here, we are seeing an erosional base to this feature, but within that sand bed, we are seeing soft sediment deformation. And here we see a fairly large tree trunk within the lignite bed.
If you have enjoyed the video to this point,